Next problem. A random variable capital X has the following probability distribution. The probability distribution given with X and P of X values. X values from 1 to 8 and the corresponding probability values are given. So we need to find the value of K and probability of X less than or equal to 2 and probability of 2 less than or equal to X less than or equal to 5. So we know that the total probability is 1. So that is sigma P of Xi equal to 1. So adding all the probability values which are given from 1 to 8, your value is 36K. Equate that one to 1. So 36K equal to 1. So K equal to 1 by 36. So by substituting this K equal to 1 by 36 in the given probability function, you will get the new probability function with numerical values. So now next one, probability of X less than or equal to 2. X less than or equal to 2 means probability of X equal to 1 plus probability of X equal to 2. So probability of X equal to 1 is K plus probability of X equal to 2 is 2K. So we'll get 3K, that is 3 by 36. I request all the students to make a note of this problem. All the problems you have to make note. Next problem, probability of 2 less than or equal to X less than or equal to 5. So you need to write the probability values between 2 and 5, including 2 and 5. So probability of X equal to 2 plus probability of X equal to 3 plus probability of X equal to 4 plus probability of X equal to 5. So from the given table, add all the values from 2 to 5, you get 14K. So that is 14 by 36. Right? So after solving these values, again you can write the probability distribution table by substituting K value. So your new table becomes with X and P of X values. X is 1 and P of X is K. So K equal to 1 by 36. And the next, second one, 2, 2 by 36. 3, 3 by 36. 4, 4 by 36. 5, 5 by 36. 6, 6 by 36. 7, 7 by 36. 8, 8 by 36. So that is the probability function. Next problem. A random variable capital X has the following probability distribution with X values and P of X values. X values 0 to 8 and the corresponding probability values are given. We need to determine A and the probability of X less than 3 and the probability of X greater than or equal to 3 and probability of X which lies between 0 and 5, and we need to write that distribution function capital F of X. Solution, we know that the total probability is 1. So sigma I equal to 0 to 8, P of X equal to 1. So by adding total given probabilities and equating to 1, we get 81A equal to 1. After simplification, that is A equal to 1 by 81. Now we need to calculate the probability values. Probability of x less than 3. Probability of x less than 3. So probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 only. We are not including probability of x equal to 3 here. So the values are 9a. Total probability is 9a, that is equal to 9 by 81, which gives you 1 by 9. Now coming to the next problem, probability of x greater than or equal to 3. Probability of x greater than or equal to 3 means, so more than 3, that is 3 plus probability of x equal to 3 plus 4, 5, 6, 7 plus probability of x equal to 8 we need to calculate. So instead of that one, what we are writing, probability of x greater than or equal to 3 equal to 1 minus probability of x less than 3, because already we know the value of probability of x less than 3, that is 1 minus 1 by 9, so that is 8 by 9. Now next one, probability of 0 less than x less than 5. Probability of 0 less than x less than 5. So that is calculating all the values from the table. (24a). 24 by 81. Next, what we have to find? We have to find the distribution function f of x. So that is probability of x less than or equal to x. So first one, x less than or equal to 0. So that is a 1 by 81. And next one is probability of x less than or equal to 1. Means you need to add a plus 3a. A plus 3a. So that is 4a. Next, second, 2. Probability of x less than or equal to 2 means a plus 3a plus 5a. That is 9a. Next, corresponding to 3. Probability of x less than or equal to 3. Third value, fourth value. So a plus 3a plus 5a plus 7a. Similarly, solve all the values. Write down all the distribution functions. Probability of x less than or equal to 8, last one. Add all the values. We'll get 81. So 81 by 81. The value is 1. Right, next problem. The probability density function of a variate capital H is the probability given probability density function, probability of x, p of x with 0 to 6 and corresponding probability values are given. So we need to find the value of k and probability of x less than 4, probability of x greater than or equal to 5, probability of x which lies between 3 and 6 including 6, and what will be the minimum value of n, so that probability of x less than or equal to n which is greater than 0.3. Already we solved this kind of problem, one problem, right? We'll solve this one. So solution, since we know that the total probabilities is 1, so sigma I equal to 0 to 6 p of x equal to 1. That is 49k total value. Adding all the probability values, 49k equal to 1. That implies k equal to 1 by 49. Next one, probability of x less than 4. Probability of x less than 4 equal to the values up to 3 we need to consider. So that is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. K plus 3k plus 5k plus 7k, that is 16k. That is equal to 16 by 49. And the next one, probability of x greater than or equal to 5. So that is equal to probability of x equal to 5 plus probability of x equal to 6. Substitute the values. That is 11k plus 13k. So 24k. And next one, probability of 3 less than x less than or equal to 6. So that is equal to probability of x equal to 4 plus x equal to 5 plus x equal to 6. 3 values we need to consider. Next, last one. So what will be the minimum value of n? So the probability of x less than or equal to n which is greater than 0.3. So for what value of n, this probability value is greater than 0.3, that we have to find. So first, probability of x less than or equal to 1. So means you need to take k plus 3k, that is 4k. So 4 by 49. So you have some fraction value, that is 0.081. So next consider other value, probability of x less than or equal to 2. So check with 2 now. So up to 2, including 2, you have to take the values of probabilities. So your total probability value is 9k. 9 by 49, 0.18. Now check with another value because it is not greater than 0.3. So take another value for probability of x less than or equal to 3. So you'll have the value as 16k. That is 16 by 49. That is equal to 0.32, which is greater than 0.3, which is greater than 0.3. So that is the observation. Probability of x less than or equal to 3 is greater than 0.3. So since this is greater than 3, so what is the value of n? The value of n is 3. Right, let's solve one more problem. From a lot of 100 items containing 3 defective, a sample of 4 items is drawn at random. Let the random variable capital X denote the number of defective items in the sample. Find the probability distribution of X when the sample is drawn without replacement. Right? So we are taking the X values, that is 0, 1, 2 or 3. So number of defective items we are taking as X. So that may be 0 defective item, 1 item, 2 item or 3 item. Because we have only 3 defective items containing 3 defectives. So X values are 0, 1, 2 and 3 only. Total number of items 10 items. And total number of good items, defectives 3. Therefore 10 minus 3 equal to 7. Total number of defective items are 3. So this is the given values. Now corresponding to each X value, we need to find the probabilities. That is, we need to calculate the probabilities for X equal to 0, X equal to 1, X equal to 2 and X equal to 3. So that is the problem. So first probability of X equal to 0 means that is equal to probability of no defective items. Means we need to select all good items. So how many items we need to select? We need to select 4 items. So sample of 4 items we need to draw at random. So probability of no defective items equal to 7C4 by 10C4. 7C4 by 10C4. So that is combinations. Simplify that one. We'll get 1 by 6. And next one, probability of x equal to 1. Probability of x equal to 1 means probability of selecting one defective item. Selecting one defective item means we need to select 3 remaining good items. So probability of x equal to 1 is given by 3c1 into 7c3 by 10c4. Because there are 3 defective items, you need to select one. So that is 3c1 into, you need to select 3 good items out of 7. So 7c3 by 10c4. On simplification, you will get 1 by 2. Next one, probability of x equal to 2. Probability of x equal to 2 means probability of 2 defective items and 2 good items. So that is 3c2 into 7c2 by 10c4. On simplification, you get 3 by 10. Next, probability of x equal to 3. Probability of x equal to 3 means we need to select 3 defective items. So that is probability of 3 defective items and 1 good item. Because we need to draw 4 samples at random. So that is equal to 3c3 to 7c1 by 10c4. After simplification, your value is 1 by 30. So now you have all the values. You can write the distribution function. That is probability distribution function of a random variable capital X, which is the number of defective items. X is number of defective items. So write down the table X with elements 0 to 3 and probability values. Probability of X is 1 by 6. Probability of X equal to 1 is 1 by 2. Next 3 by 10 and 1 by 30. Let's see one more problem. Let X denote the minimum of 2 numbers that appear when a pair of fair dice is thrown once. Determine the discrete probability distribution. Here probability distribution function is not given, so we need to construct it from the given problem. So here 2 pair of dice is thrown. So your total sample space with 36 elements, that is total number of outcomes is 6 square, that is equal to 36. So what is your H here? H denotes the minimum of 2 numbers. Minimum of 2 numbers. So that is for minimum 1. So you need to calculate for minimum 1, minimum 2, minimum 3, minimum number is 4, minimum number is 5, and minimum number is 6. So first, for minimum 1, favorable cases are, so you need to write all the combinations like 1 comma 1, 2 comma 2, that is not 2 comma 2, that is 1 comma 2, 1 comma 1, 1 comma 2, 2 comma 1, 1 comma 3, 3 comma 1, 1 comma 4, 4 comma 1, 1 comma 5, 5 comma 1, 1 comma 6, 6 comma 1. That is combinations with all ones you need to write because minimum number should be 1. So 1 should present in your sample space. So you will have 11 favorable cases from sample space. So probability of x equal to 1 is 11 by 36. For minimum 2. Minimum 2 means the number in the favorable cases with 2 and it is minimum number. So write down all the combinations with minimum number as 2. 1 రాయకూడదమ్మా. సో 1 comma 1, 1 comma 2 ఉండదు. మినిమం 2 comma 1 ఉండదు. మినిమం నంబర్ 1 ఉండాలి. మినిమం నంబర్ 2 ఉండాలి. Write down all the possible cases, that is favorable cases. Minimum number is 2. So 2 comma 2, 2 comma 3 you can write, 3 comma 2 you can write, 4 comma 2, 2 comma 4, 5 comma 2, 2 comma 5, 6 comma 2, 2 comma 6. So these are the favorable cases. So that is 9 by 36. Probability of x equal to 2 is 9 by 36. In this way, you need to write for minimum 3, minimum 4, minimum 5, and minimum 6. So your probability distribution function with probability x values 1 to 6 and probability values are 11 by 36, 9 by 36, 7 by 36, 5 by 36, 3 by 36, and 1 by 36. So this is for today's class.